keep bumping into the digitalization of energy, and I bump into water for the same reason. It begins with meters, and it just ends up covering the entire supply chain from end to end. So one of the things that's really interesting to me is not just energy and water, but all of the different infrastructures that are more and more converging around the criticality of the information infrastructure to support it all. So I'm really excited to see this presentation from you, and with that, please proceed.
Thank you. Great. It's super to be here, and I have been working on water for 2 years. Our institute, as many of you know, does a lot of work on electric utility of the future, and so for me there's sometimes a sort of a parallel dialogue as I focus in on water questions and then think, so what's the analog on the power side? Nonetheless, preparing this talk was kind of fun because it really made me focus in on what are good ways to discuss that. And I guess I'll just flag one thing up front, which is I think we really like these to be very discussion-based, and so I have kept my slides on the lighter side. As I prepped, there were a number of things where I actually decided I could put that in, but I'm not going to. It may flow from discussion, it may not, so I'm really open to this going off in a number of directions. And the 12 or so slides I have are really just designed to form a foundation. We can also break into discussion before we get through the slides. Comments and questions are welcome at any point. Good, well, let's get started. I have a few slides just setting some context, and then wanted to focus in on some particular challenges, changes that I think can move us towards solutions to those challenges, and processes to pursue those changes. And then at the very end, I've got a few examples of people who are already acting on this in a variety of different ways. Before I begin, I like to just sometimes pause and just note that we got up this morning, probably one of the first things we did was use the bathroom and flush the toilet, brushed our teeth, got a glass of water from the faucet, and probably didn't really pause to think what a miracle it is that at any moment in time, we, under the vast majority of circumstances in this country, can get water reliably with confidence that it is safe to drink. There are obviously the incredible and tragic exceptions such as Flint. There was the Cape Town crisis last year. So it does break down sometimes, and obviously that has a profound set of effects that are devastating in some cases. But nonetheless, it's kind of amazing how well this works. The other thing I just wanted to comment on, sort of given our overarching theme for the seminar series, is even if we maybe momentarily pause and think about how this water came from a source, got treated, went through a hole in the pipes, we probably then don't think about the amount of energy needed to do that. Similarly, when we consume energy, we rarely reflect on how much water was needed, whether it's cooling the plant, or any number of ways in which water can be involved in those processes. So just kind of wanted to pause for a moment and acknowledge the incredible complexity as well as the tight coupling between our water and our energy systems. I'm going to focus in a little more on the water side overall, but really happy to discuss the exact nexus. I decided to mainly focus this on water with reference to analogies with the energy sector. So in terms of context, just like electricity, the typical water utility in the US is seeing per capita demand decrease. That can be partly a result of technology, that can be partly a result of behavior. On this slide, I just put some data. We have a close partner, which is a city in Texas called New Braunfels. It's just outside Austin. We've been working with them for about 6 months. You'll see their GPCD came down from a little under 200 in 2010, 200 gallons per capita per day, to something around about 145 in 2018. This is a water utility that has had some modest conservation efforts, but they haven't really been going all out. Actually, one of the things we've been talking to them about is your conservation has been good so far, but here are ways in which we think you can bring down that number even further. More broadly, when you kind of look across the country, you obviously have certain places where supply is becoming more severely constrained as climate change takes an effect. California, most notably, but also Colorado, Texas, Florida. A lot of utilities are kind of trying to figure out what does that change in supply circumstances mean. One of the things about managing demand and managing supply is that it's actually not uncommon for water utilities to lose about 20% of their water to leaks between the source and it actually reaching somebody's house. And I think utilities are becoming increasingly conscious that for all the cost of that is just folded into customer rates, that they can be a lot better at managing those leaks, and some utilities have managed to get down much lower to say around 12% or something like that. So utilities who focus in on that generally have success at bringing that number down. One of the things about the water industry is, people who work with the electric utilities say, wow, they're sometimes a little slow to change and sometimes rather risk averse. I feel like that's generally about 3 times more true in the water industry. I don't want to sound overly critical in the sense that the utilities have a profound responsibility around public health, and there are all sorts of reasons why they should be thinking about lots of questions as they think about possible changes. But nonetheless, it's pretty incredible, I'd say, that there are many water utilities that haven't really enacted much notable change at all in a very long time. We're starting to see smart meters get deployed in water. It is also slow, but we're getting there. Once those are in, it's just incredible what can be done with it. Although it is also true that a water utility might not always have all the data handling techniques and knowledge to utilize what you can get out to smart meters. So I think one of the big changes on the water side, as on the electric side, is just utilities getting more on top of these are the staff we need to leverage smart meters to deal with big data, and that's actually one of our topics of discussion with New Braunfels. They have smart meters, they're excited, but they really feel like, wow, what next? So that's a real area of opportunity. I think overall, I just flag that increasingly as you go to conferences in the water space, the questions utilities are asking are less about how do we meet demand and more about how do we manage and meet demand. And so I think, again, there's an analogy there with the electric utility in the future. It's less about we are simply selling a commodity and we are selling as much of it as the customer wants, and it's more, what are the services that we can provide to help people manage their water? So, for example, with New Braunfels, we were talking about opportunities for them. They're supply constrained. They had some real concerns around that, and we managed to explain to them their concerns were probably actually not quite as big as they thought they were, in the sense their demand was growing less fast than the utility thought it was. But nonetheless, one of the ways in which they had gone after conservation was focusing in on people who violated their watering ordinances. And we said, sure, really understandable to focus in on your violators. Then we said, how about you focus in on your top consumers and go and talk to them about why are they consuming so much? Is it just the nature of a business they have, or is there some other reason? And it was actually really interesting. We surfaced that with them in around about September, October, and by December they said, we've started talking to those people and we're already seeing reductions in consumption from those accounts. They realize they have leaks. They realize they can make behavior changes. They realize they don't need to irrigate their landscaped area when it's just rained. So utilities are starting to realize the opportunities of that nature. A little on price of water and how that couples into how much gets used. Here's one table where the average price per gallon, cents per gallon, is in descending order for about 12 countries. What you see is the consumption is really kind of bouncing all over the place. So you've got somewhere like the US, where you've got a pretty low price and a pretty high consumption, but then you've also got somewhere like Australia, where you've got a relatively high price and high consumption. There are many, many studies of elasticity out there, and I think Josh spent a lot of time on this with us last summer. I think it's pretty fair to say there isn't really a whole lot of clarity on elasticity in water pricing and use. A few other comments on cost and price. One is just how the intrinsic cost is really dependent on the source. So for example, we work with San Antonio, which sits on top of the Edwards Aquifer in Texas. Really high quality water. So much of the San Antonio water is simply extracted from the Edwards Aquifer. They do a really minimal treatment because it's all they need to do, and then they pump it out, and their costs are so low just because they've got this fabulous resource. Here we are in Massachusetts, in Boston, a lot of our water comes from the Quabbin, just gravity fed into the city. Sometimes you just get really lucky with your natural resources, and sometimes you don't, and then you've got massive treatment to do. You see utilities doing interbasin transfers, and then you're funding a giant pipeline and the costs associated with that, even before you're getting into the operating costs. So I think that's one of the things that's notable about water, just the simple cost of how much it costs to get water from its source to customers can really vary very dramatically. At this point in time, there's an increasing dialogue around a few things that are really going to drive some notable price increases in the coming years. One is a lot of our water infrastructure is very old, and it needs to either be replaced, as in a new version of it installed, or some different infrastructure needs to be built. Whatever route we take, it's going to cost something, and that's going to drive some cost increases. There's also an understanding that supply variability is going to drive cost increases. People may realize they need to go to aquifer storage and recovery as a kind of backup resource, or any number of other approaches. So that's looking like it could drive prices high pretty quickly, and associated with that, of course, is the challenge of affordability. One other comment is, it's in this analog of water versus power. One thing about water is storage is really easy. Storage can be a reservoir. So unlike power, where storage is the holy grail at this moment in time, it's so straightforward on the water side. And so when you can think about different rate structures that can be useful for water utilities, and that again is a very active area for discussion right now. Time of use rates aren't useful in the same way on the water side, although seasonal rates may be useful. If we're looking to shave people's summer use of water, when of course people want to use water more, but the precipitation tends to be lower, then some kind of seasonal rate structure may be useful. But finer increments of time, probably not so useful. So those were context slides. I just want to kind of frame what I see as a core problem, a core challenge across the industry. One of the things we find in talking to different utilities is their problem of the day varies widely. But so often, in some bigger picture sense, at least 2 or even 3 of these challenges are at the root of some of what's unfolding day by day, week by week, month by month with them. As we know, we've got urban populations that are growing really rapidly. Our research right now at the ISC is all in Texas, and there we've got both San Antonio and Austin that are both in the top 10 cities in terms of rapid growth rates in the US. I was just reading, so Austin is projected to quadruple its population from about 1 million to 4 million, and that's driven them to write a 100-year water plan that we'll touch on a little more later. We've also commented already, water infrastructure is aging. Many pipes are increasingly vulnerable, and that does in some cases tie in with those leaks that achieve a 20% loss rate for the water utilities that I referenced earlier. And then natural supplies, whether it's more intense drought, more prolonged drought, deluge, where utilities may well be responsible not only for getting the potable water to their customers, but potentially also managing stormwater, and how do we minimize hazards associated with stormwater, but maybe even how do we capture stormwater and utilize it rather than just push it away from our built environments as quickly as possible. All these questions around climate change and changes in precipitation patterns are pretty profound. Just to get a little more precise on that crossing issue I mentioned earlier, there was an article a couple of years ago that indicated potentially some water prices are going to be increasing by 41% in the next 5 years. Now, admittedly, for most of us at this point, water is incredibly inexpensive, and there's a reasonable fraction of the population for whom that kind of level of increase is, it might raise an eyebrow, but we're not going to be worrying about our water supply. Of course, there is a section of the population for whom that is absolutely not true, and for whom those kinds of price increases are a real challenge. So really, as we've kind of worked through a lot of different questions as a team at the ISC, we've kind of focused in on what are the things that make a utility sustainable, resilient, and its water affordable to people? So sustainability is often about thinking about what are the long-term implications of how you source your water. In Houston, they pump so much groundwater, they can detect the subsidence from that groundwater pumping. It is measurable, and I don't know if you know the number off the top of your head, Bob, but it's pretty eye-popping. It's been a while since I looked up that number.
I don't know the number, but
anyway.
It's true.
So sustainable is about what are the long-term implications. It's one thing to say we're just going to suck water out of this basin and pump it into another basin, but what are all the ramifications of that, and thinking about that. Resilience is both about water supply and water management, as in that stormwater piece. It's also fiscal resilience for the utility. As utilities see that demand per capita dropping, they have to think about how do they maintain their fiscal liability. And another thing is, of course, going back to that seasonality, they need to be confident that they remain fiscally secure in a dry summer where people want a ton of water because they want to keep their lawns at least half green, or a wet summer where actually people don't need to be doing that much outdoor irrigation. They can really just get by allowing the natural rainfall to manage their landscape for them. And then affordability we've touched on already. So when we started work 2 years ago, this work is funded by the Mitchell Foundation, and they really wanted us to focus in on how can integrated water management solutions in Texas help urban utilities address those three challenges I put up previously. And they actually framed it in a really open way. They said, go talk to people in Texas, figure out the stakeholders in our system, understand the legal and the regulatory factors, and then let us know, who do you think the key agents of change are? And so the team dug in for about 6 months. We talked to a whole variety of people. We talked to the water manager in a small Texas city who said, I'm happy to talk to you, just don't come and visit because the water issues are so intense here. I go into the city with protection because I receive death threats associated with my job. So we talked to a lot of people on a lot of things. And we really came down to, if Mitchell Foundation wanted to focus in on one set of stakeholders as being at the hub of driving change, we said we think that is the utility. It's the utility that brings together, or can bring together, municipal planners, developers, and engineers. And we've actually seen how this can unfold in a couple of different ways. San Antonio has truly developed a very integrated approach to its growth planning as they think about what buildings to build and what homes to build as they expand their city for new residents. They are bringing in the city planners with the water utility, with the power utility, with the transportation specialists, and with the community as well. And it's really a very active discussion with very clear choices around, depending on how we build, there are these trade-offs in these aspects of people's day-to-day lives. That's San Antonio. Austin Water has gone about it a rather different way, a very large city, but they have they brought in engineers to do incredibly detailed studies of different options that are available to them, and they've really thought through many different pathways in a very detailed sense. And it's all been the utility that's driven that, and to be honest, the utility that has procured the money from the city to get some massive engineering studies complete. So as you kind of think about the utilities at the center of everything, you've got both opportunities and you've got challenges. They really develop these plans around so many aspects of the treatment and distribution process, as well as the supply process. One of the things that is a little tough is they tend to have fairly long-range plans. Everybody has a 5-year plan at a minimum. Many of them have 20-year plans, sometimes even longer than that. And once something has got into the plan, it can be hard to displace it with an alternative. So that's the positive and the negative on that side. Everybody, of course, has some level of forecasting that they engage in. People are receptive to changing those methods to varying degrees. We had one conversation with the finance people in Austin who said, well, it might change, but we're just going to engineer our way out of it. We've got the money to do that. And we kind of got into this discussion of that's been your status quo approach for a long time, and how long is it that you can maintain that without encountering some major challenges? You've also got the utilities in a position to think about different ways of investing in their capital and other possible business models. And this whole decoupling can be done in the water industry just as it has been in the power utilities. I'll admit, that feels like a stretch conversation in the water industry right now. Margaret, who was on the team last year, and I were at a water conference, and we overheard some water utility folks saying, did you know there's this thing called decoupling? And apparently they've done it in the electric utilities, and I want to go and figure out what it's all about. So of course, where we sit, it was sort of amazing that there were these pretty serious utility planners for whom this was news in summer 2018. We've also got the opportunity to explore different rate structures and pricing of water in the utilities. Of course, various regulatory aspects to that as well. We are seeing some utilities pursue different pricing mechanisms. It is slow to develop any movement in that regard.